Hello, here we are again. I'm at it again. Some more upgrades. This time it's just one, and it was my gyro. Alright. As you can tell, it's the JR-G270-3D. It's a MEMS gyro, so it doesn't have any of the issues that the piezoelectric ones have. Anyhow, the purpose for the upgrade. I was having a lot of issues with my JR-G250. A lot of people have used them without any issues. Unfortunately, I just could not get mine to work. Maybe it was faulty, I don't know. So I decided that I better spend a little bit of money and invest in some quality. You can pick these up for about $110. I wasn't able to find them any cheaper than that unless you go to like eBay or whatever, but I didn't go there. So I just stuck with A-Main Hobbies and went ahead and ordered it brand new. It got to me in about a week. Week and a couple days actually. So how do we install this thing? It's just like any other gyro. You're going to put it on the gyro mounting plate, which on the T-Rex 450 Pros, it's on the anti-rotation bracket. When you do install this, ensure that you leave some kind of gap back here between this upright and your gyro, just so you don't get any unnecessary vibrations on the gyro itself. This gyro does come with 2 pieces of foam sticky tape. I went ahead and stuck the 2 pieces together, stuck it to the back of the gyro, trimmed it up so that it was nice and flush with the gyro so I didn't have any overhang, and then I went ahead and stuck it to the gyro mount. Now as far as the cable running, I ran it underneath the gyro mount, and then I brought it down the left side through the inside of the frame. See, when I flip this over here, it does come underneath, comes around this screw up here. It comes around this screw up here, right here, and it comes through here. Zip ties here, comes around this little opening. Zip ties here, comes through here, and then it comes out a hole that's behind my receiver. And where the wire actually goes through the carbon fiber, I have a zip tie just so that I know I have enough clearance. And the way the zip tie is set up, it's set up to help hopefully stop the cables from touching the carbon fiber. I will be keeping an eye on that just to make sure that I'm not getting any unnecessary wear and tear on the wires, because after buying this thing, I don't think I want to buy another one. And then your tail servo does plug into it plugs right into the gyro. There's some cutouts up here that you use, and because it is keyed, it is a keyed hole, so it will only go in one way. Black wire goes towards the front of the helicopter, and your white cable goes towards the tail of the helicopter. Alright, so let's discuss the stuff that's on the top of the gyro. This very first dip switch, okay, the one that's closest to me or closest to your tail servo connection, alright, that is your deadband switch. It has 2 modes. It has 0 and low. I'm going to start off in the 0 mode just to see how the tail reacts. Basically what your deadband is that if you put it on 0, the gyro is going to automatically correct for any disturbances in the tail. Any disturbances in the tail. Anything that's minor, it will correct for it. And then the low is in case if it has that feeling like it's still overcorrecting and you start getting the oscillation in the tail where it starts swinging from left to right. They state that if you switch the switch down to low, that could help alleviate a lot of the wag that you may see in the tail. The default setting when you first open up the package is that the dip switch is in the low position. I've already switched it up to the 0 position because that's where I want to start out at. That I just want to see how this is going to react. The to make sure that my tail servo is going to react correctly with this gyro, and it should. It's an aligned DS520 servo, so I shouldn't have any issues with this tail whatsoever. Your next dip switch, the next one up, is your reversing switch. Basically, this switch is going to reverse the correction of the tail. So if you spool this thing up and this thing starts spinning in one direction or the other, and it just starts spinning and spinning and spinning, and you can't stop it from spinning, you're going to throw this switch, because right now it's in the default position, it's in the down position. Then what you'll do is you'll just flip that switch up, and that should stop the crazy pirouetting of the helicopter as you spool up. You'll know it's going to do it as soon as it starts spooling up, so be mindful of that. Take it easy on the first couple of spool ups until you know that your gyro is set up correctly. And now the potentiometer. This is your travel limit for the tail. You can't see it right now, but I'll try and demonstrate this here in a little bit. The potentiometer is used to set the travel of your servo. When I go into the radio setup, I'll explain more about it, but basically this is just shifting the endpoints either to the left or to the right so you don't have any binding. And the idea is to get that set so that you're not binding in both directions, and you want to try and get it as center as possible, or as close, so that your pitch slider is as close to center as possible. And I'll cover more about that in the mechanical setup. So you won't be able to adjust this until the mechanical is done. I've already fired up and I've already set the travel on this, so I'm not gonna mess around with my setting. It works for what I have. I don't have any binding to the left or to the right, and I'm happy with how it's correcting. So so now on to the next step, which is going to be the mechanical setup of the helicopter itself. Alright, first, as with any basic setup, when you first build your helicopter, your servo arm, when it's plugged in and on rate mode, you want this servo arm to be 90 degrees to the body of the servo. According to the directions, they want it 90 degrees to the body of the servo. So you need to pay attention to that. Alright, now your linkage rod, okay, is going to have to be adjusted so that your tail pitch slider, try and get this on the camera for you, your tail pitch slider needs to be as center as possible. Okay, you want this to be as center as possible on the rotor shaft. Alright, and you do that by adjusting your linkage rod. Okay, you're either going to tighten it or loosen it depending on what direction you have to go. Basically, the counterweights on the blade grips, that's what I used to make sure that it was center. When the two counterweights were perfectly aligned with one another, I said, okay, that's good to go. So that's how I centered it when I set this up already. Alright, and that's pretty much it for your mechanical setup. The other thing that you're going to want to pay attention to is on your servo arm. Alright, you need to pay attention to your ball linkage. Alright, your ball linkage, which is right up in here, or down here for me. Alright, you need to make sure that that is at the correct placement for your servo. Every servo is going to be different. This is the DS520. I have it set at 10 millimeters from center to center. It's center of the screw that holds the horn on to the center of the ball link itself. So you want to make sure that you got that set up correctly. Alright, and that's pretty much the mechanical. It's pretty simple, straightforward. I thought it was going to be more complicated than that, but it's not. So now we're going to go into the radio setup. Alright, here we are, the radio. Alright, the first step, okay, is make sure down here that your rudder trim is perfectly zeroed. Okay, you want this at 0 for this particular gyro. The instructions will tell you that you need this to be centered. Okay. Next, you're going to want to go into the menus. All right. The first screen that we're going to take a look at is going to be your reversing rudder. Okay. Right now mine's set for normal. Okay, it's set in the regular direction. I don't have to reverse it right now. We'll make that adjustment once we get outside and actually start trying to fly this thing. Next, you need to go into your sub trims. Okay, on your rudder. Okay, you want this thing to be set at 0. There's my rudder right there. You want that thing set at 0 for sub trims. Okay, that's just what the directions say to do, so that's what I did. Next, you need to go into your endpoints. Okay, and I go down. As you can see, hopefully, I have my rudder set at 120% both left and right. Okay, there's the left, there's the right. They're both set at 120. Directions say to set it at 120, so I set it at 120. You're giving the maximum amount of servo throw for your servo by doing that, and a little extra. So the directions say to do it, so I did it. Revo, okay. I don't have this set up at all. This is stock. This setup is nothing. It's how it sets up when you set up a new model for this radio. I am not touching this because I'm going to be flying mostly in head hold mode. This is more for the people who like to fly scale and you're flying in rate mode. And again, you'll set this up in accordance to your the manufacturer of the helicopter. But I am not going to be messing with this at all. But this is another option that you may have to look at for your setup. And that's pretty much, come down here and let's take a look at gyro sensor. Alright, gyro sense menu option, okay. I'm starting out at 68. Typically you start out at 65. I'm going to start out at 68 just to see how things go. I have it set up for standard mode. The other option is, I can't remember, it's for the GY series motor gyros. Since I'm not running a GY, I'm just going to keep it on standard. In my down rate mode, which is your regular rate, non-head hold mode, I have it set at 45. I'm probably not going to even mess with that at all because I don't have any intentions on flying in rate mode at this time. But my up rate head hold mode, I have it set up for 68. Now I can make adjustments later once I get outside. And that's pretty much it for the radio. And at this point, we are now ready to take this thing outside. Before I do that though, I want to cover one quick adjustment that I had to make, but it's not to the gyro, it's to my main gear. Okay, I was having motor heating issues. I don't know if it's just typical of the Scorpion motor that I'm using. I don't know if it's typical of that brand, for this motor to get hot and for the ESC to get hot. So I figured, let me check the gear mesh just to make sure that the gear mesh isn't too messed up. The receipt paper that I used may have been too thin or whatever the issue was, because I didn't have any play in my main gear. Currently I didn't use any register tape. I didn't even eyeball it. I left the servos in when I did this. I just loosened up the motor, re-thread locked it, secured it back into place, and I just made my adjustments. And just by the feel, I have just the slightest amount of play. I mean, it's ever so slight. So we're going to find out if this takes care of my heating issues with my motor. And now that we have everything pretty much zeroed out. We have everything basically set up for the gyro. The other thing the directions are going to tell you is that they don't want you to mess with the gyro sensor adjustment until after you've flown the first time. They don't give a time limit. Just get it up off the ground, hover it for a couple of seconds, set it down, then take off again, and then see if you have any wag or anything like that. The gyro does need to calibrate itself while it is in flight, so keep that in mind. It's going to calibrate your pitch for you, or I mean not your pitch, but the trim for the tail. It's going to calibrate all of that stuff for you automatically on the first flight. Okay, so don't make any adjustments on the first flight. Just get it off the ground, hover it for a little bit, set it back down on the ground, and then go back into a hover again and see how things are looking for you. Alright, so on to the flight. don't know what the hell happened there.